So I'm Dan Lathrop. I live 3 doors down from Nick. So this is actually a picture from about a month and a half ago, and I guess, so Heidi and Elaine are here. So there are a handful of projects going on in my lab right now, which is over close quarter field work, so it's about 2.5 blocks that way. All of my work, generally speaking, is in nonlinear dynamics, chaos, turbulence, geophysics, okay, a few other things. But the current activity that bears on geophysics really are 2 projects and an upcoming project. One of the projects is, so if you see the sphere there, so that's the 3-meter diameter liquid sodium model of the Earth's outer core. And if anybody cares for a lab tour, we can arrange that easily, or for the department if that's of interest. So we have a rapidly rotating, turbulent, metallic liquid sodium experiment to try to look at how rotating turbulent induces magnetic fields as happens in the Earth's outer core. So we try to understand the core dynamics of the magnetic field with that. And actually, Elaine Scheller, the new in charge of that experiment, which is, it sounds daunting, but they ran it, so it's...
No fires yet.
No fires to date, right?
Yeah.
Well, you had the fire training, so it's good. So Heidi Myers is the lead graduate student then on another NSF-funded project where we're developing a geophysical sensor suite for finding unexploded ordnance and landmines. Although we discovered that that suite can be used to also find things in urban settings, utilities and otherwise. And so here's just a picture where this is Tetramag, so the setup that was built by the team with 4 flux gate 3-dimensional magnetometers. And so a very sensitive system in a variety of ways. You can see the metro from the lab, you can see space weather from anywhere around here pretty easily, and stuff in the air or surface as well. So yeah, there's a FLIR camera, which is here, actually. It's upside down, that will also be pointing at the ground. So there's a variety of other suites we're working on. And then starting in January, presuming that we get funded, there's a number of colleagues here that are involved in this University of Maryland methane and wastewater heat remediation problem. And this is a campus map where I map all of the fumaroles on campus over the summer. So there are 55 active fumaroles on campus with steam coming out of the ground. I'm sure all of you have seen them. They are neither desirable, intentional, and actually about 20% of the wastewater is going into the river, changing its pH. Sujay has been monitored for years. We now know why. It's sodium hydroxide out of the steam condensate that's going into the river, which is kind of terrible. So, and then other parts of the team, we've been mapping methane emissions from campus as a kind of microcosm of urban, suburban, environmental issues using campus as our laboratory. And then with Russ Dickerson in Atmospheres and Oceans, we'll be flying and producing a methane emission map of the state of Maryland as a pilot project with the Civil Air Patrol doing the flights that we hope to scale to other states to do methane emission mapping. So, thanks.